Tonight's talk is 11.8 in your textbook. You should take a look at this. And we're going to be talking about bonding in solids. It's a very short talk tonight. So what's going on in solids with respect to bonding is what we're all about tonight. And so basically the physical properties of solids, things that we've talked about in class, things like melting point. In solids, we're also interested in things like hardness, like how hard a diamond might be. Now, these properties depend both on the arrangement of the particles and the attractive forces between them. So we're just going to be talking about a couple solids really quickly here tonight. So let's start off with molecular solids. And these are going to be atoms and molecules held together essentially by intermolecular forces. They're going to, because these are, as we know, intermolecular forces are very weak, we're going to have low melting points. In molecular solids, I tend to look at these guys as either just atoms or molecular compounds. And we have a couple different ones we can look at. You know, we have argon, which is just going to be a collection of atoms. If we add some pressure, we can liquefy that guy. Things like methane or even dry ice, which I'm going to show you a little bit of video about dry ice here in a moment. Essentially, the intermolecular forces that are going to be present in these types of molecular solids, you could just have London dispersion forces, which are probably the most common. Occasionally, you might have some dipole-dipole forces and possibly even some hydrogen bonding if you have hydrogen directly bonded to NO or F. I want to show you a little video on dry ice, which is nothing more than solid carbon dioxide. And so let's take a look at this real quick.
Today on Sci Guys, Boo Bubbles.
Welcome to another episode of the Sci Guys. I'm Mark, and on today's episode, we're going to be making boo bubbles with dry ice.
And I'm Ryan.
Dry ice is the solid state of carbon dioxide. Carbon dioxide will freeze at temperatures below minus 78 degrees Celsius. For this experiment, we're going to need a pop bottle,
Rubber tubing,
a funnel,
a small bowl,
a little bit of dish soap,
and a whole bunch of dry ice.
The safety equipment we're going to need for this experiment include an apron or lab coat to protect from spills and splashes, and a thick pair of gloves for handling the dry ice. You should never pick it up with your bare hands as it can cause frostbite within seconds.
The first step in our experiment is to take your funnel and your rubber tubing and place your rubber tubing either inside or over top of the small end of the funnel. The second step is to take your dish soap and pour it into your small bowl.
For our third step, we're going to take our bottle and fill it up about half full with hot water. At that point, we're ready to put in about 5 or 6 pieces of dry ice.
The final step is to dip the rubber tubing into the dish soap, then press the funnel tightly over top of the 2-liter bottle. This forces the carbon dioxide gas through the tubing, creating smoky CO2 bubbles. You can also do this with a smaller pop bottle to make a portable smoky bubble blower. Let's look at this experiment a little closer. Dry ice is frozen carbon dioxide. To freeze CO2 into a solid state, it needs to be cooled below negative 78.5 degrees Celsius. When we drop pieces of dry ice into our 2-liter soda bottle that contains hot water, we are quickly heating the solid carbon dioxide. Warming up our dry ice forces it to change state from a solid to a gas. The warmer the water, the faster this process will occur. The bubbles that are produced in our 2-liter bottle contain the escaping carbon dioxide gases. This process happens at such a rapid rate that the airspace in our bottle is quickly filled with CO2 gas, which quickly produces a greater volume of gas than the bottle can contain. So the gas shoots out the top of our bottle. When we place the funnel over top of our bottle, the smoke builds up inside the bottle, causing an increase in pressure. This increased pressure builds up and forces the carbon dioxide gas through our rubber tubing, which then presses against the seal of dish soap coating one end of our rubber tubing, producing smoky bubbles. The bubbles will pop if they come in contact with dirt or oils. So to get them to land without popping, rub a little bit of dish soap over the surface of your plate. This creates an oil and dirt-free surface, which is perfect for your bubbles to land on.
Well, that's it for Boo Bubbles. Thanks for watching.
And if you like this episode, let us know in the comments below and subscribe for future updates.
Also, like us on Facebook and follow us on Twitter.
And if you have any questions related to this experiment or about science in general, feel free to message us in the comments.
Okay, so that was a quick explanation on what's going on with dry ice, carbon dioxide. They didn't mention, and they should have mentioned, that would never want to contain or put a top on that container with the carbon dioxide or the dry ice inside there, because it could easily build up enough pressure and explode, sending little shards of plastic all over the place, including through your body, which you would never want to have happen. So, the last type of solid bonding that we're going to talk about, we've already talked about metallic bonding, those free-floating electrons. We've already talked about ionic bonding. Let's talk about a covalent network solid. And essentially what these are atoms that are held together in a large network. And they're held together by covalent bonds. And so what we're going to take a look at really quickly here is we have diamond and graphite. They're both allotropes of carbon. And so the diamond itself, this on the left-hand side here, you've got a diamond or a carbon molecule there, a carbon molecule there, a carbon molecule there. They're all being held together by single bonds, covalent single bonds. For each carbon, you got four single bonds, or there's being bonded to 4 other carbon atoms, and they're bonded covalently in a 3-dimensional way. And that 3-dimensional way allows, it's why diamond is so hard. Diamond will scratch glass and things like that. It's used for drills and things like that if you want to go through rock. And it's due to that strength of those covalent bonds in between those carbons. Graphite's the same way. It forms hexagon rings, and you get these sort of rings, like as you can see here, laying flat, and then there's our carbon there, and there's a carbon there with a single covalent bond. But then you also have bonds going up like this, and that's what graphite is all about. Those are both good examples of covalent network solids. And that's really all we have to say about bonding and solids, as we've already talked about the other two. And so, short lecture.